my name is Kaylin, and for my discrepant event, I will be doing an experiment to see what materials conduct electricity. Now, before I get started, I want to explain the connection to the program of study this experiment has. This event will fall under grade 5 level and will be under a topic of electricity and magnetism. For the specific learning expectations, it falls under number 4, demonstrate that a continuous loop of conducting material is needed for uninterrupted flow of current in a circuit, and number 5, distinguish electrical conductors, materials that allow electricity to flow through them, and from insulators, materials that do not allow electricity to flow through them. For materials, I will be using a bulb, test lead, battery, coin, paper clip, eraser, and copper wire with plastic coating. However, if I was in a classroom setting, I would have students working as a group using these materials, as well as other materials like toothpick or aluminum foil. But to save time, I'm only using the 5 materials to test their ability to conduct electricity in this video. Procedure, I will be putting the red lead to the positive side of the battery and the black lead to the negative side of the battery. I will then attach the second black lead to the bulb. I want to test the connection by touching the second red lead to the bottom of that same bulb, and I know that I have created a proper circuit if the light bulb lights up, which it has. I'm thus gonna test some more materials like the coin, and I know whether it's a conductor or not if it lights up the light bulb. If it does not light the light bulb, I know that it is an insulator. At this point, I would also have my students predict if they thought this coin and the other materials we will be testing will conduct electricity or not. And as we see, this coin is indeed a conductor and has created that complete circuit, and we know this because the light bulb has lit up. For our next material, we will be using paper, and we can see that it is not completing that circuit, so therefore that paper is a insulator. We're then going to be testing a paper clip, and it lit the light bulb up, so I know that that paper clip is a conductor because it's completing that circuit. Next, we are going to try an eraser, and it is not lighting that light bulb up, so unfortunately that is an insulator. I'm going to be using a copper wire, and I'm using the ends to test first to see if wires are an insulator. Nope, they are a conductor. They are lighting that light bulb up, but we are also going to test the plastic on the outside of that copper wire to see if it is also a conductor. And it is showing me that it is not a conductor, it is an insulator because it's not lighting that light bulb up. So here's a quick diagram of our experiment. This is the battery, these are the leads leading to the conductor and insulator, and this is the light bulb. Now, not all materials allow these electrons, the little e's on these pink particles, to flow, free flow. So materials made from conductors like the coin, the paper clip, and the wire that we used in the experiment enable the electrons, these little e's, to flow freely from particle to particle. Thus, charged objects will always distribute its charge until the overall repulsive force between electrons are minimized. If another object touches a charged conductor, the conductor can even transfer the charge to that object, just like how this conductor charged this light bulb. However, an insulator, such as the eraser and the paper and the plastic on the wire, prevent these electrons from free flowing from particle to particle. Thus, if a charge is transferred to an insulator, the extra charge will remain in the initial charging location. Where these leads are is where the last electrons were flowing. And the insulated particles do not permit the free flow of the electrons, so these aren't going to move from particle to particle. As a result, the charge will not be distributed evenly across the surface of the insulator, and it will not light up this light bulb.